Welcome to Learning Math with Mr. Tan. Today we'll be looking at the sketching of quadratic graphs where the equations are factorized into linear factors of x minus a and x minus b. Typically, this is a difficult topic as there are many concepts involved and they require some connection between algebra and the understanding of Cartesian plane. Today I'll be breaking down some of the concepts for you. Do join me for the exploration of the concepts if you're learning it for the first time, but if you're just revising this topic, then you may want to go to the timestamp in the description below to look for the parts of the video where I describe the derivation of certain features of the graph. So these might be more relevant for you. So let's start learning. Over here on the right, there is the Desmos template which you can use and is publicly available for you to use by scanning the QR code on your handout over here. And you can go into this template to either explore on your own or explore together with me. Now notice over here there is a blue color graph and a red color graph. The blue color graph is for the situation of y equals to x minus a multiplied with x minus b. Now the values of a and b are controlled by the sliders in item number 3 for a and item number 2 for b. So you can actually slide this around to control the values of a, slide this around to control the values of b in order to understand this concept. Also, you notice that there is a red color graph which is for y equals to negative x minus a multiplied with x minus b, and I'm going to hide this for now and let us focus on the situation of the blue color graph. So I'm going to move this graph as well, and also if you need to zoom out to see, for example, the y-intercept which is actually missing over here, you can actually zoom out to change the scale actually, and on your mobile device what you can do is pinch to zoom and zoom out. Before we get started, I'd like to bring your attention to this equation over here. We are more familiar with the general form of y equals to x squared plus bx plus c for the situation of a equals to 1 where the coefficient of x squared is 1. Now what I'm trying to do here is to make a bit of connection with the factorized form, so don't worry so much about this. Focus more on the factorized form. So in the first row over here, we have the situation of a equals to 2 and b equals to 3. So first I need to slide the slider for a to 2. Okay, you can actually change the value directly by clicking this. Okay, so now we have the correct graph. What we need to do is to zoom in a little bit more so we can see clearer. And we have the x-intercept where the graph cuts the x-axis. This is the y-intercept where the graph cuts the y-axis. Now notice two things. First, my x-intercept is 2 and 3 which I put over here. Y-intercept is 6 which I put over here. Also importantly is for x-intercept, y equals to 0. So the y-coordinate is 0. For y-intercept, x equals to 0. So notice this opposite effect and keep this in mind. This is going to be important for our later part of the activity. So also notice over here I have the expanded form. So let's look at the x and y intercept with relation to the equations. Now for the factorized form, I have x minus 2 multiplied with x minus 3. Notice that if I solve x minus 2 equals to 0, I get x equals to 2. If I solve x minus 3 equals to 0, I get x equals to 3. Also, look at the constant in the expanded form. It is y equals to 6. And notice that this is actually the y-intercept. Next, we go into the line of symmetry. This is the green color dotted line that is running through the graph and is cutting it into two symmetrical parts. Now this, if you notice, is halfway between the x-intercepts. So essentially, if you do it algebraically, you actually just find the value that is between 2 and 3 and it's halfway. So it's actually the mid value of these 2 points, or taking the mean of 2 and 3. So you get x equals to 2.5. Now also notice that this line of symmetry actually happens to run through the turning point or the minimum point. So notice that the turning point has x coordinate of 2.5, which is actually the same as the line of symmetry. Okay, and the y coordinate, you just simply substitute the x equals to 2.5 into the equation. Okay, so that concludes the first row. Now what about the second row? So what I'm going to do is to slide the slider for b to 4. Okay, we need to zoom out a little bit to show all the features that we need. So we have the x-intercept. We also have the y-intercept. Okay, so let me just zoom out a little bit more so it's clearer. Okay, so for x-intercept, I actually have x equals to 2 and 4. So over here, what I'm going to do is to write down x equals 2 and 4. And y equals to 8. So again, it is the same thing. If I solve x minus 2 equals to 0, I get x equals to 2. X minus 4 equals to 0, I get x equals to 4. Also, the constant in the expanded form becomes the y-intercept. So unsurprisingly, if you realize over here, this is actually your line of symmetry, which is x equals to 3. And x equals to 3 is actually halfway between x equals to 2 and 4. So we have over here x equals to halfway between 2 and 4, right, is 3. And the turning point, we will have the x coordinate of 3. So over here I can make it appear x equals to 3. And then if I substitute x equals to 3 into the equation, I would get y equals to -1, which you can verify on your own. So I'll leave this with you for now and let you try the last two rows on your own before we come together again to make a general observation. So what you can do for now is to pause the video and get started on the next two rows of this table. Right, you may resume this video when you are ready to generalize the last row. So before we get started on the generalizing of this whole situation, I would like to talk you through about a equals to 3 and b equals to -5 and how this impacts the factorized form. So previously we have not dealt with negative values of a or b, so let's be a bit careful. If you have made some mistake, it's probably because of this. So a equals to 3, b equals to -5, we have the general form of y equals to x minus a multiplied with x minus b. So if a equals to 3, I have x minus 3 over here. If b equals to -5, I have x minus -5. So be a bit careful over here. What I actually should have is x minus 3 multiplied with x plus 5. So it's over here. Okay, so be very careful about this. So same thing for the fourth row, you have the same situation. The -2 and -3 for a and b respectively is going to give you y equals to x plus 2 multiplied with x plus 3. So now I'm going to show you the situation on the graph for a equals to 3 and b equals to -5 first. Okay, so for this situation, I have x-intercept of -5 and 3. So I have over here x equals to 3 and -5. The y-intercept is -15. Again, notice this, the x-intercept always has y equals to 0. The y-intercept always has x equals to 0. Okay, and then we have the line of symmetry, which is -1. So x equals to -1 over here. And this is halfway between -5 and 3. So again, all these observations seem to be consistent. Okay, I'm not going to show for the fourth row. You can verify for yourself. If you have made some mistake over the factorized form, it might be good for you to go through this one more time by pausing the video. So I'm going to make a bit of general observation now. Okay, so a bit of observations. Now, the first thing that I get really interested in is the fact that if I solve the linear factors, I actually get the x-intercept. So for example, if I solve x minus a equals to 0, I actually get x equals to a. And this actually is my x-intercept. Okay. Second, my observation is that the constant, oops, let me try to erase that. So my constant in expanded form is the y-intercept. Okay, that leads to the y-intercept. So we'll put that in more specific form over here later on. And point number 3 I observe is that the x-intercept always has y equals to 0 as the y coordinate, and then lastly y-intercept always has x equals to 0 as the x coordinate. So we'll put this observation aside first. So we are going to generalize this. So like I mentioned, my x-intercept for the situation of y equals to x minus a multiplied with x minus b is just x equals to a and b. So again, this is by solving the linear factors of x minus a and then solving it equals to 0, you get x equals to a. X minus b equals to 0, solving it, you get x equals to b. Now the constant over here of the AB is actually the y-intercept. Okay, sometimes we are more familiar with the general form of x squared plus bx plus c, so it's actually y equals to c, so it doesn't matter. So what we can do is actually just take the value of a and b and multiply them together to get the y-intercept. Okay, so that's based on the factorized form. And then for the line of symmetry, what we have is actually the two x-intercepts. We take the mid value or halfway between these two values, we get x equals to a plus b over 2. Then lastly, this a plus b over 2 becomes the x coordinate of our turning point, and then we will substitute that x coordinate into the equation and we get the y coordinate. So the next part of the video, I'm going to show you some example of how to sketch this graph by putting all this understanding into the working. So if you are just looking to revise this concept, you can actually go direct to this part. So in example 1, we sketch the graph of y equals to x squared minus 2x minus 8. And this can be factorized into x plus 2 multiplied with x minus 4. In the exploration part of this video, we already deduced that when we solve the linear factors, we actually get the x-intercept. So this is like we solve this x plus 2 equals to 0 as well as x minus 4 equals to 0. And we get the x-intercepts of negative 2 and 4. Okay, so this is consistent with the fact that we observe that the x-intercept always have y coordinate of 0. So it's like we substitute y equals to 0 into the original equation, and then when we solve for the x, we simply get the x-intercept. So all these concepts, they are interconnected. Now what if I need to put the x-intercept into coordinate form? So we just simply put in the first one, which is negative 2. So x equals to negative 2. And the y is 0 for x-intercept. Next, we also put the 4, which is x equals to 4 into the part for x coordinate. And then we put y equals to 0 for y coordinate. So that's for x-intercept. Now remember that in the next part, there are certain interconnected ideas. Now these three parts is up to you which order you find them out. Sometimes the question will specify whether they want you to state or show clearly the y-intercepts or the line of symmetry and so on. So depending on the complexity of the question, the requirement of the question, you may be allowed to leave out certain parts, but generally it's the safest to show all the features. So for these three features, it's up to you which order you find. I personally prefer to find y-intercept first because it's quite algebraic. You could also find the line of symmetry easily from the x-intercept by taking the mid value, okay, and that would lead you to the turning point. So for this, for finding the line of symmetry, it is just simply finding the value exactly between -2 and 4. So you kind of take the mean of the two values, okay, and that gives you x equals to 1. So x equals to 1 is the equation of the line of symmetry of this graph. And as well, that means the x-coordinate of the turning point is 1. Remember that the line of symmetry passes through the turning point. So x equals to 1 as we have. And to find the y-coordinate, we substitute this value of x into the original equation. Now you could choose to substitute into the factorized form or the original form. So I personally prefer to substitute into the original form. So what I'm going to get is 1 square minus 2 times of 1 minus 8. And that's going to give you -9. So you have x equals to 1, y equals to -9, and the coordinates of the turning point is 1 and -9. Now later on, when I touch about the shape of the graph, I will talk a little bit about whether this turning point is minimum or maximum. Actually, it is quite intuitive. So let's get to that later on. So the last feature that you may need to show is the y-intercept. So remember I said if you're finding the x-intercept, you substitute y equals to 0. You find the y-intercept, you substitute x equals to 0. So again, you have a choice to substitute into which equation. But clearly, if you substitute into the original, it will be easier. Or if you could recall that the constant in the expanded form is the y-intercept, then this is simply just y equals to -8. So the y-intercept is -8. If we were to put it into coordinates form, that means it will be x equals to 0, y equals to -8. Before we start sketching the graph, we need to go back to Desmos once again to deduce one generalization about how the shape of a quadratic graph is affected by whether it is positive x squared or negative x squared in the equation. I've taken a snapshot of the essential working and information we have found so far with regards to the graph, and let's go back to Desmos once again. So over here, I've set a equals to 2 and b equals to 3 in the slider. So the blue color graph is actually y equals to x minus 2 multiplied with x minus 3. And the red color graph is actually y equals to negative of x minus 2 multiplied with x minus 3. Now notice that these two graphs only differ by having a negative outside the bracket in the red color graph equation. So essentially, this y equals to x minus 2 multiplied with x minus 3. If we were to expand this expression on the right, we actually get y equals to x squared minus 5x plus 6. And for the negative situation, what we have is a negative outside of the x minus 2 multiplied with x minus 3. And then first of all, that will give us this step. And lastly, we have negative x squared plus 5x minus 6. Now the difference between these two, first of all, is that the first one is positive x squared, second one is negative x squared. Which means the blue color graph is actually positive x squared situation, whereas the red color graph is negative x squared situation. Notice that the blue color graph is shaped as such. So it looks really like what we call a smiling graph. In proper terms, the blue color graph would be called concaving upwards, whereas the red color graph would be called concaving downwards. But for simplicity, I'll just refer to the blue color graph as a so-called smiling graph, whereas the red color graph as a frowning graph. Okay, so you could also refer to this blue color graph as a happy graph and the red color as a sad graph. So from this point on, I will just refer to the blue color graph as a happy graph and the red color graph as a sad graph. So the positive x squared situation gives us a happy graph, so it's smiling, and the negative x squared situation over here gives us a sad graph, which is a frowning graph. So back to this example over here that we are trying to sketch. Now remember that in this equation we have x squared and it's positive. So this graph is actually the happy graph situation. So the graph should be a happy graph situation, therefore it should look something like this. Okay, but first of all, we need to label our axis. So this is the y-axis and this is the x-axis. I normally put 0 over here. And so now we are good to sketch. Now the first thing I will put in is actually a negative 2 over here. Okay, that will be for my x-intercept, as well as the positive 4 over here somewhere. Now to ensure that your graph is quite proportionate, you could consider using a ruler to measure, okay, but it's not necessary, but it will help your proportionality. So therefore, just to get a rough gauge over here, double of that interval should be somewhere here. Okay, so if you use a ruler, just if you want to be really accurate, you can actually measure off 2 cm here and 4 cm here, but that's up to you. So a smiling curve will look something like this. It's going to pass through these 2 points. Now, to make sure our graph is shaped correctly, we need to first of all put in the y-intercept as well. This will ensure our graph hits the minimum point at the correct part of the Cartesian plane. So this y-intercept is actually -8. So you could also measure 8 cm, it's up to you, and you can put in -8 over here. So you're now good to actually sketch in the curve. Remember that this quadratic graph is symmetrical. Okay, so therefore you would not make any mistake about where the minimum point is. So you could sketch like this. If you put in more information, it might put in more restriction in your drawing, so it might make the sketching a little bit more difficult for you. Okay, so I'm going to sketch. So in any case, for example, like this, when you're not happy, you can actually erase it. Okay, and then you can sketch it one more time. So it's up to you. So I'll leave these to you to try to make sure your graph looks quite symmetrical and passes through all these important points. So once you are happy with your graph, what you can do next is to put in the remaining information, starting from the line of symmetry, which you can draw a dotted line, right? And you can label the point where it cuts through the x-axis as x equals to 1, and label the equation for the line of symmetry. And at the minimum point, you could also label the y coordinate, which is -9. Okay, so once you have all these points, you could also be even clearer by putting in the coordinates. I don't feel that's necessary, but if you feel that it's the safest, well, you could actually put in the coordinates for the minimum point. But it's actually more important for you to draw a dotted line to indicate that the minimum point has a y coordinate of -9. So one last thing to perfect your graph is actually to put in the equation of the graph. And that's it, you are done. So the next part of the video will be looking at an example which involves sketching the graph of a situation where the x squared is negative. In example 2 over here, we sketch the graph of y equals to negative x plus 3 multiplied with x minus 5. We can expand this and eventually get y equals to negative x squared plus 2x plus 15. And in our discussion earlier on, we deduced that the constant term is going to give us the y-intercept. And the x-intercept is going to be given by the factorized form. But I have a concern. What about the negative outside the bracket? Is this going to affect the x-intercept? Let's go into Desmos to find out. So in Desmos over here, I have the situation of a equals to 2, b equals to 3. You can set this to any other value and observe the same thing. So over here, we have the blue color graph to be y equals to x minus 2 multiplied with x minus 3. The red color graph differs by the negative outside the bracket. So it is y equals to negative of x minus 2 multiplied with x minus 3. Now look at the x-intercept over here. Okay, I marked these two x-intercept out. Now notice that these two x-intercepts lie on both the red and blue graph, which means to say both of them have the same x-intercept, and therefore that means this x-intercept is unaffected by the negative outside the bracket. And therefore, back to here, what we can do for our first step to find the x-intercept is to solve the linear factors, which is x plus 3 equals to 0 or x minus 5 equals to 0, and we will get x equals to negative 3 or x equals to 5. So right now, once you get this, you can directly label onto your graph. So I have the y and x axis. I can measure off 3 cm from 0. Let's say I measure off here as 3 cm, and then measure another 5 cm from 0 on the right. Okay, and I can already label this. Now, bear in mind that this is going to be a frowning graph, a sad curve. Okay, now the next thing is I can find what is the y-intercept to determine where it will cut the y-axis. So I can also choose to find what is the line of symmetry and so on, but I feel that y-intercept is sufficient to give us a really good sketch of the graph. So I find the y-intercept, and recall that finding y-intercept means I substitute x equals to 0, or like I mentioned earlier on, you can get it from the constant term in the expanded form should you choose to take the trouble to expand it. So either way, you're going to get y equals to 15. So you can choose to measure off 15 cm or anything in that proportionate way, and probably you can go up to, let's say here, it's 15. Okay, and you can start to sketch. Again, if you're not happy, if it looks something like this and not really symmetrical, you can draw again. Okay, so after you have drawn this curve and you are satisfied with it, you can start to label in other features of this graph as well. So the next thing you need to find, for example, is the line of symmetry. So I'm going to put SLOS, line of symmetry. And recall that this is the midpoint between the two x-intercepts. So x equals to negative 3 plus 5 divided by 2. And that's going to give us x equals to 1. So that's the equation of the line of symmetry. Okay, and is this dotted line over here, x equals to 1. And then this x equals to 1 happens also to be the turning points x coordinate. So for the fourth thing I'm finding is the turning point. Now remember earlier on I've talked about turning points as well as minimum maximum point. So it's quite intuitive. If let's say it is a set curve, it has to be a maximum point. There's no way it can turn in such a way that it is minimum. Likewise, if it's a happy curve, it has to be a minimum point. So for the maximum point, okay, the x coordinate follows from the line of symmetry, and then we're going to substitute this back into the expanded form, which is kind of easier. So I have y equals to negative of 1 square plus 2 times of 1 plus 15, and that's going to give me 16. Okay, so we can actually label here carefully as 16, and we now have the graph. So next is we actually just make it perfect by labeling the equation. So for the line of symmetry, I have x equals 1. You could choose to put it below if that's too close to the y-axis. So can put x equals 1 over here, and for the curve, you put the equation y equals to negative of x plus 3 multiplied with x minus 5. So I hope this video has helped you in understanding how to sketch quadratic curves which can be factorized into the factorized form. Okay, if this video helps you, please like my video, and if you feel that my channel is helping you in mathematics and helping you to improve and grow in mathematics, please subscribe my channel and spread the words to others. Thank you so much for watching this video. Goodbye.